Bismillahirrahmanirrahim. Assalamu Alaikum, dear student. Welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus physics SSC2 National Book Foundation unit number 11. Sound according to SLO base or FBISC requirement, comprehensive exercise short question answer. Now, today we will discuss question number 7 to 9 in part 3. Previous part we can discuss question number 4 to 6. So we can solve question number 7. In question number 7, what is loudness of sound? On what factor does it depend? So first of all, we write the definition. Loudness, the greater of sound energy. The loudness of a sound is loud. So the loudness is depend upon the amplitude or also called the depend upon height of sound wave. So we can simply say that loudness is directly proportional to square of amplitude. Now we will discuss about in explanation the loudness of sound enables us to distinguish between finite and loud sound. So loudness is depend upon the following factors. First of all, the area of vibrating body. Larger the area of vibrating, larger will be the amplitude of sound will be produced. Now we can also say that distance from the source of sound. In this question, loudness is also depend upon the frequency and the distance of the body. The loud sound have a distance is increased. So increase or decrease in a distance between the source of sound and the listener, decrease or increase. In this definition, we can simply say that loudness is inversely proportional to distance of the source sound. We can say that if the loudness of sound is increased when distance is decreased. If the loudness of sound is decreased when distance is increased. In general, we can explain that if the distance between the source and the listener is less than, then we can produce a loud sound. If the distance between the listener and the source is greater, then we can hear the less sound, or we can in a audioable range of 20 Hz to 20 kilohertz. Now we will discuss about material through which the sound is travel. Now we can say that amplitude of sound wave in a different material such as water and air. Now we will discuss about in an example a drum produce loud sound if it is a strong length and the vibrating body is starting to oscillate with a large amplitude, and therefore sound is produced also a large amplitude and result of sound is louder. Now this is the loudness depend upon the factors of these bodies. Now we will discuss the question number 8. What is the intensity of sound and what is the range of intensity of audible sound? Differentiate between loudness and intensity of sound. In this question, we will discuss about that sound intensity is defined as the sound power per unit area. So, the usual contact is the measurement of sound intensity in a air at a listener location. Now, the basic unit is a watt per meter square or also watt per centimeter square. Many sound intensities measured are made related to the standard third sound, hearing of intensity. The most common approach to the sound intensity is measured to be a decibel scale. Now, sound intensity is inversely proportional to square of distance from the sound wave source. So we can say that sound intensity is inversely proportional to square of distance from the source sound wave when the source is coming. Now we will explain this answer more example. Since the sound wave carries its energy through a two-dimensional or three-dimensional medium, the distance of the sound wave is decreases and increasing in the distance of source. Similarly, we can also say that the decreasing in intensity with the increasing in distance is explained by the fact that have the wave is being distributed over a great surface area. Since energy is conserved and the area through which is energy is transmitted is increasing, so the intensity must be decreases. Now we can say that the amount of sound energy passing each second through the unit area is called the intensity of sound. We sometimes use the term loudness and intensity are interchangeably. Why? Because but they are not in a same. Loudness is a measure to the response of air of sound. Even when two sounds are the equal area of intensity, we may hear one of as a louder and other is simply because our ear detects it better. So loudness is a subjective quantity and intensity is a objective quantity. Now we can say that this is the difference of audioable frequency range. There are both upper and lower limit of the sound frequencies of human hair. Now, hearing quality is depend upon the healthy and young person. So here we will discuss that a healthy man or a person or frequency range about 20 Hz to 20 kilohertz. Here we can write that 20 Hz to 20,000 Hz, the upper limit decrease with the age. So physicists have the established a three-part of classification of sound based on the range of human being hearing. Now we can infrasonic wave. What is a infrasonic sound wave? Sound frequency lower than 20 Hz are referred to as a infrasonic. So these sound waves cannot be heard by human being. These sound produced by a elephant and other example are infrasonic waves. Now in a B part audioable sound. The sound frequency in a 20 Hz to 20,000 Hz range are a audioable sound. In third part, we will discuss the ultrasonic sound. So ultrasonic sound wave, the sound frequency is higher than 20,000 Hz are known as ultrasonic. So the sound cannot be heard by a human being because this is the reason. So these are outside and audioable range. The sound produced by a beats are very powerful. So the wave can be used in a medical or scientific and industrial field and vice versa for their purpose. So this answer is complete. Now we will discuss the type of difference between loudness and intensity. So write the difference between loudness and intensity. What is made by loudness? Loudness is a measure of response to the air of sound and intensity is the sound power per unit area. Similarly, loudness is measured in decibel, but intensity is measured in watt per meter square and also watt per centimeter square. Loudness is depend upon the sensitivity of human ears, but intensity is depend upon the sensitivity of human ears. Now, in question number 9, define the intensity level and derive the formula for its decibel. So, first of all, discuss what is meant by intensity level. Now we will discuss the sound intensity level or also called intensity level. The difference between the loudness of two sounds, where one sound is a finite sound and audioable range of as known as intensity level. Now explanation: an average human ear can detect the sound intensity as low as 10 raised to power minus 12 watt per meter square and higher as 1 watt per meter square. This is incrementally with the range of intensity and spanning the factor of 10 raised to power 12 to lowest and highest. Now here we can denote it by the loudness is L and intensity of sound by I. So if L is the loudness and I is the intensity of sound in watt per meter square, then we can write the mathematically form L is directly proportional to log of I. Here we can write that L is equal to K log of I. When removing the proportionality sign, we can use a constant that is equal to K. So we have K is a constant or also called a proportionality constant. If L naught represents the loudness of finite sound and I naught is the intensity of sound, then we can write that I naught is equal to 10 raised to power minus 12 watt per meter square. So we write the equation L naught is directly proportional to log of I naught. Here we can write that L naught is equal to K log of I naught. Then we have two equations and subtracting both equations. Then L minus L naught is equal to K log of I minus K log of I naught. Taking common K, then K into log of I minus log of I naught. Here applying the logarithm rule, we can write that L minus L naught is equal to K log of I over I naught. Here K is a constant of proportionality. Now we have write the difference between the loudness of two loud sound, then L minus L naught is intensity level that is denoted by beta. Beta is given by beta is equal to K log of I over I naught. So we can write that beta is defined in the term of similar quantities ratio. It is the unit less than the value of k and depends not only the unit of I and I naught but also on the unit of intensity level. So if the intensity of any sound is 10 times greater than the intensity of I naught, then we have write that I is equal to 10 I naught. Then the intensity level is such as a sound is taken the unit in a bell and also k is equal to 1. So we have write that subtracting by values. So L minus L naught is equal to beta. Now here k is equal to 1, then equation is beta is equal to log I over I naught into bell. Now we have, since the bell is the largest unit, so the intensity of sound is often expressed in the smaller unit, that is decibel. So beta is equal to 10 log of I over I naught dB. Here dB stands for decibel. So we write that it is must be remembered that one bell is equal to 10 decibel. Best of luck with remaining question in the remaining video.